Welcome. This is your Unit 8 test study guide. Objective number 5, the calculator inactive section. So if you've got your calculator out, go ahead and put that bad boy away. Um, and we're going to talk about graphing Jesse's bus ride here. Okay? So Jesse's bus ride to school is 5 minutes less than 3/7 the time of Robert's bus ride. Create an equation and draw a graph. Okay? So create an equation. We need to know what our M and our B are. Okay? And to draw a graph, we'll also need to know those informations as well. Now this is a word problem, so you're going to need to go through and translate. First thing you need to do is figure out what do we not know. Well, we don't know what Jesse's bus ride is. Okay? So I like to put relevant variables. So I'm going to put a J, if I can write one. Now my capital J looks like this. Okay? The word, and the other thing we don't know is Robert's bus ride. So I put a R for him. Okay? So instead of using Robert's bus ride and Jesse's bus ride, I'll use J and R. Okay? The word is right here means equals. And then 5 minutes less than. Less than means subtract, but it's a special subtract where it means minus 5. Okay? And then it says 3/7 of Roberts. 3/7 of Roberts. That's 3/7 times Robert's bus ride. So now if we clean this up down here, you get Jesse's ride equals 3/7 times Robert's ride minus 5. Now remember that minus 5 has to go at the end. Okay? So now if we break this down, it's really in y equals mx plus b form, because y and x are like j and r, and 3/7 is the m, so that's the 3/7, and the b is negative 5. Okay, so this is part 1 of the question. Write me an equation. Part 2 is you have to draw a graph. So when you do that, you want to begin with B. And then you want to move M, the slope. Okay? So we begin with B, which is the negative 5. So I come down here to negative 5 and I make me a dot. It's the y-intercept, that's why I go on the y-axis. Okay, so you always go up and down on the first one. When you begin in the middle on that number that it is. Okay, now we're going to move M. Well, M is 3/7. That's our rise over our run. Okay, so now we rise up because it's positive, and we always run right. Rise over, run right. R, R, R. Okay, so we're going to rise 3. 1, 2, 3. And we're going to run right 7. 1, 2, 3, 4, 5, 6, 7. And so it actually goes off the page, but it's right there. Okay? And now I'm going to connect the lines. Okay? Make sure I got all that. Connect our dots. Boom. There is our line. Okay? Next question. Given this function, describe how f of x and f of x plus 3 would compare on a graph. Okay? So you got to understand the terminology. F of x is telling you that f of x is 2x minus 7. So it's like saying f of x is y equals 2x minus 7. And f of x plus 3 means they're going to add 3 to the whole function f of x. So you have f of x is 2x minus 7, and f of x plus 3 really means 2x minus 7. And then here, let's do some color coordination here. This is like plus 3, so you would just go plus 3 to the whole thing, okay? And so if we just do the mathematics behind it, we really don't need the parentheses. So the 2x minus 7, you just tack on the plus 3. Well, now you simplify, and so you get 2x, and negative 7 plus 3 is negative 4. Okay? So that's what f of x plus 3 equals. And so I'm just going to rewrite f of x right below it so that we can see what it looks like. So if you look at these two equations now, how do they compare? Well, they have the same slopes, okay? And f of x plus 3 has a different y-intercept that is 3 more than the old y-intercept, okay? And I'm going to make this red so that when I draw the graph you'll see in different. So I'm going to graph one in red, and I'm going to graph one in purple, and you'll see which line is which. So, like I said before, the slopes are going to be the same, and the y-intercept's changed, and it looks like f of x is plus 3. The y-intercept just went up 3. Okay, so the first line we have, we begin at negative 7, so that's down here, underneath the 6, okay, and then it's going to rise up 2 and go over 1, rise up 2 and go over 1, 2 over 1, 2 over 1, 2 over 1, 2 over 1, okay, so then I draw my graph. Okay, that's going to be the graph of that one. So now we do the purple one. It's going to start at negative 4 and go up 2 over 1, up 2 over 1. Alright, and had I drawn that graph correctly, let me see, let's see if I can fix it. There we go. A little bit better. Okay, so we look, and it just shifted the graph up. And if you count, it goes up 1, 2, 3. So it moved it up 3 spaces. Okay? And that's all it's really going to do. This shifts the graph up 3. So they'll have the same slope, which means they'll be parallel. I don't know if you can see that. These lines are parallel. They'll never touch. Okay? And it shifts it, graph, up 3 units. Okay? That's all you need to know about that particular situation. So, Deshaun wants to buy some cookies. He has $20 in his pocket, and the cookies are $1.25 each. The situation can be modeled by the function here, where T of C represents the total cost of the cookies. C, cookies. State a reasonable domain and range for the situation. So, domain, that's going to represent all possible x values. Okay? Range is going to be kind of like the counterpart to that. It's going to say all possible y values. And so when it says state reasonable domain and range, it wants you to say, like, what would make sense in real life terms. And sometimes you got to do one and then do the other one and then go back and fix the other one based on the parameters. Okay? And parameters are like the things restricting you in the question. So if you look, our restriction is he only has $20. So that's going to limit the amount of money we can spend total. Okay? And so that's going to limit the total cost of the cookies. Okay? So, I mean, not total cost, the total number of cookies we can buy, because we can only buy enough cookies that would go up to $20, right? So, but in real life, what's the least number of cookies he can buy? Well, assuming that he went there and he just maybe he didn't do it. Yeah, he could buy one cookie. That'd be the lowest he could technically purchase. But he could also choose to buy 0 cookies. Okay? But then he could continue to go. And we know that we're talking about cookies for the x value because c is where x normally is, and c is also the x, like when you do f of x, t of c, c is like the x, and x is like cookies. Okay? So that's how we're talking about cookies. So now, but he can buy more cookies than that. He can buy all the way up to $20 worth of cookies. So the way you would do that is you would take the total cost as 20 equals $1.25 C, divide by $1.25. Okay, and you will get 16 cookies. Okay, so the most number of cookies he can buy is 16. So he can go anywhere from 0 to 16. And the way you write that is his cookies can go from 0 to 16. Got it? So now all the possible y values. Well, the y is talking about the total cost of the cookies. So what's the lowest total cost of the cookies? Well, if he bought 0 cookies, he could have $0 he spent for the cookies. Okay? And then what's the most that his cookies could have cost? Well, that's limited by our parameters, $20. Okay? Now, sometimes they could get really specific on how they want you to talk about the domain and range. Okay? So, like, for example, when you're talking about cookies that he's buying, this technically says every number between 0 and 16. But can you technically purchase every option between 0 and 16? No, because you can't purchase 0.25 cookies. That doesn't make sense, right? You can't purchase a quarter of a cookie. They won't let you do that. So sometimes they might get really specific and say use the integers, whole numbers, something to that effect. Okay? But for the range, technically the price can be anywhere from 0 to $20. You can have change in there, especially if you throw in tax into the equation, things of that sort. Okay? Question number 20, the final question. Create a graph of this equation. Okay? So most of you will graph easier from y equals mx plus b. There's two ways, so I'll show you both ways. And so first we'll talk about y equals mx plus b. Okay, so you have 4x plus 3y equals 15. Um, so we want it to be y equals. So the first thing we're going to do is move the x to the other side because it's not on the side we like it on. Okay, and then 4x minus 4x is 0. Be very careful to pay attention to your sign. So you get positive 3y equals, and then negative 4x, and that's a positive 15. Okay, so notice really how just the 4x moved to this side. Okay, now we need to divide by the 3 in the front. Got it? So you get 1. Y equals negative 4 over 3x, and 15 divided by 3 is positive 5. So you would start at positive 5 on the y-axis. Remember, because you begin with b, and then you move, and this is, so b equals 5, so that's why we started there. And m is negative 4 over 3, which means we're going to move down 4 and always to the right 3. So let's do that in red. Down 4, 1, 2, 3, 4. So it's 4 blocks down. 1, 2, 3, 4. And 3 blocks right. 1, 2, 3. Or 1, 2, 3. And we'll make our new point right here. And then you want to repeat the process as many times as you can to fill up the graph. 1, 2, 3, 4. And then 1, 2, 3. So it's right there. And then you want to connect your dots. This is blue. And that's how you create the line of this graph using y equals mx plus b form. Now, let's look at this line. If you didn't use y equals mx plus b form, it would be a little bit less accurate on the draw, but if you're trying to draw it quick for something on the EOC where it's not really necessary for you to do an extremely accurate drawing, like you just need to get like how much slope does this have compared to another line or something like that, then you can use this method, and it's the intercepts method. And it works out really well if everything is divisible by each number, but in this case it's not. So for the x-intercept, you're going to essentially cover up parts of the question. So when you're looking for the x-intercept, you don't need the y. So the y will go away. Okay? And so you have 4x equals 15. So that's where, if we do x-intercept, okay, you get 4x equals 15. And if I wanted the y-intercept, just erase this back, put it back up there, plus 3y. The y-intercept happens when there is no x, or when you put 0 for x. And so you have 3y equals 15. Okay? And so we'll go through and solve these. Divide by 4, divide by 4. X will equal, and then it's probably easier for you to do this in decimal form. So 4 goes into 15 3 times, and then you have 3/4 left over, or 3/4, you get 3.75. Okay? And then divide by 3, divide by 3, y will equal, and you get 15 divided by 3, which is 5. Okay, so now we'll go and plot these points. So for x, you get 3.75. And now I'll show you guys. I feel bad because this is the calculator inactive part. So 4 goes into 15 3 times, you get 12. Okay, 3 comes down, so then you put your decimal point, and then 0 comes down, making it 30. Okay, so put your decimal point. 4 goes into 30 7 times, you get 28. 2's there, so you got another 0. 0 comes down, 4 goes into 20 5 times. So that's how you get 3.75. So now 3.75 on the graph is that's like 3 quarters, 75 cents. So you go to 3 and you're going to divide this in half, and then you're going to divide each one of those in half. And that's how you get your quarters. And your 3/4 mark is right there. So you just make your dot right in the middle of the middle, on the closer to the 4 side. Okay? Now y equals 5, that's really easy. That dot goes there. And then you just connect your dots. Okay? And if you had a ruler, it would make it really easy to do, but you'll just try your best to split the center, and there you go. You have your equation of your line. You have your graph of your line using the x-intercepts and the y-intercepts. This concludes the Objective 5 video, the calculator inactive section for your Unit 8 test. Thank you for watching. Good luck, study hard, do well on your test.